So this video is on National 4 Chemistry and we're covering the topic of rates of reaction. So the first thing we need to know are signs that a chemical reaction is happening. How do we know? Well, there are a few obvious ones. If a reaction is producing bubbles or it's fizzing, it's a really good sign that a reaction is happening. The other most obvious one would be if it changes colour. A colour change definitely shows you that a reaction has happened. Now the next two terms are going to be about temperature change. So a reaction can get hotter or it can get colder. And we use very specific words for these that you need to remember. So the first one is if a reaction gives out heat, and that means that it'll heat up, the temperature will increase. We call that exothermic. So exothermic, exo means out, thermic means heat, so it's giving heat out. Now the opposite would be if a reaction actually cools down. And so if a reaction takes in heat and it cools down, we call it endothermic. So endo means inside and thermic means heat. So you need to remember those two words. Exothermic for if the temperature increases, it gives out heat. Endothermic for if the temperature decreases because it's taking in heat. Now there are a few ways in which we can increase the rate of reaction, things that we can change about our reactants that would allow a reaction to happen faster. So the first one is increasing the temperature. We know that if you want to cook something faster, you increase the temperature. And cooking is a chemical reaction. If we make the temperature hotter, a reaction will always get faster. The next thing we could do would be to increase the concentration. Now concentration means how much chemical is dissolved in a reaction. And if we've got more chemical dissolved in a reaction, it's going to be able to react faster. So increasing the concentration. The third one is probably the hardest one to understand. This is increasing the surface area. Now that's what we mean. Increasing the surface area would be if we had like a big lump of chemical and we were to turn it into a powder. When it's a powder and we added that into our reaction, there's much more of that chemical that's exposed. In a lump, you've got all the stuff in the center, can't really react until the outside is reacted, but if we grind it up into a powder, it can all be exposed to the other chemical and react a lot quicker. So increasing the surface area. And the final one is using something called a catalyst. Now a catalyst is a special type of chemical which we add to a reaction that increases the rate of reaction, but what's really special about it is that a catalyst is unchanged at the end of the reaction, and it means that you can reuse it over and over and over again. So if you want to speed up a chemical reaction, increase the temperature, increase the concentration, increase the surface area, and or use a catalyst. Now, when you do a reaction, you take measurements to plot a graph. Now, there are two types of graph that you can be asked about at National 4. First one is a reaction that produces bubbles, and you can plot a graph of the volume of gas produced. And the graph will look like this. It'll start at 0, it'll shoot upwards, and then it'll curve and become flat. The second type of graph would be the mass of the reactants that are lost, because as a reaction goes on, you're using up reactants, so the mass decreases. Now the graph looks slightly different. This time, you're not starting at a mass of 0, you're starting with your reaction being at its heaviest at the start, and then as time goes on, the mass drops, so the graph goes down, and when the reaction is finished, the mass will stay constant, so the graph will become flat. Now, depending on the graph that you've got, you need to be able to use graphs to compare or tell us a few different things about rates of reactions. Now, the first thing you need to know is that the steeper the graph is, and that is how quickly it goes upwards, the faster the reaction is. So with these three graphs, reaction number 1 is definitely the steepest. And that means that experiment 1 is the fastest. Now, if we look at the other two graphs, right at the bottom there, we see that experiment 3 actually is steeper than experiment 2. Even though experiment 2 goes higher, the graph for 3 is above the graph for 2 at the very start of the reaction. And so experiment 2 is actually the slowest. The second thing we need to know is that we can tell when a reaction is finished by the time it takes for the graph to become flat. So if we look at experiment 1, and we look at the point at which it becomes flat, which is just after the curve part has happened, when it starts to become flat, and we look down to the time, it said 5 minutes, we know that experiment 1 finished at 5 minutes. Now if we now look at experiment 2, draw an arrow to when the graph first becomes flat, which is about here, it means experiment 2 finished, if we look down at the time, it finished at 11 minutes. So we can compare when reactions finish as another way. The quicker it takes for a reaction to stop or finish, the faster the reaction is. So again, we know that experiment 1 is a lot faster than experiment 2. The third thing we need to know is that if we change the concentration, or we change how much reactant we have, we will change how much product will form. So for this one, we're going to look at graph number 1 and graph number 3. Now we can see graph number 1 finishes at a much higher height. It actually finishes at double the height of experiment number 3. And this means that experiment 1 must have had double the concentration, or used double the amount of chemical than experiment 3. So if a graph finishes at double the height or triple the height of another graph, you can say that that experiment used double or triple the amount of reactants. And the final thing we need to be able to do from a graph is interpret what mass has been lost during an experiment. So a question you could get is, what was the mass lost after 2 minutes? Now to do this, you need to work out a few things. The first thing you need to know is, well, what mass did we start with? And the starting mass is always going to be where our graph begins at the start on the left-hand side. And so our starting mass here was 8.5 grams. Now the next thing is, well, we were asked what was the mass lost after 2 minutes. So we need to know what was the mass at 2 minutes. So we go to the bottom at 2 and we go up and then across, and we can read off the value from the axis, which is 2.8. At 2 minutes the mass was 2.8. And so the mass lost is going to be that change, what has changed. So it's going to be 8.5 minus 2.8 to give us 5.7 grams. So this video has been a short going over of the signs of a chemical reaction, ways to increase the rate of a chemical reaction, and then different ways of interpreting information from graphs. Okay, that is us covered all of rates of reaction, and I think the next topic is acids and bases.